Hello and welcome to week 6 of Devtoberfest. We are almost at the end of Devtoberfest and SAP TechEd 2021 is just around the corner. But that doesn't mean that this week will be boring. We'll have many exciting sessions, we'll have a fun Friday activity, and we'll also have a coding challenge for you if you still need to earn some points towards your Devtoberfest contest and that you can move your avatar to the next level. But let's start with this first session. The title is Free Your Web Apps of Speed Bumps. So why are speed bumps that slow your web applications not only annoying but also costly? So according to a Bing study, an additional 10 milliseconds of loading time for an e-commerce application can cost up to $250,000 annually in revenue. Obviously, I understand that enterprise applications might not directly generate revenue, yes, but it affects your employee engagement, your employee happiness, and your employee productivity. So it does make a lot of sense to make sure these applications are free of speed bumps as well. For this presentation, we will only focus on the front-end part of web applications, as this is the front-end week of Devtoberfest. But obviously, web application optimization doesn't end there and continues in the back-end as well. Let's have a look at the agenda for this week or for this presentation. At the first, I will introduce you to the structure of this presentation. You will see later on what I mean with that. Then we'll talk about some general optimization strategies or options that you have when you inspect your web application that hold for all web applications. And then we'll have also a deeper look into UI5 based web applications. Followed by that, I'll give you an optimization tip, how you can basically approach an application with a not so good performance and make it better based on the options that you've previously learned about. And last but not least, I want to introduce you to this week's coding challenge, where you can apply everything that you learned directly to earn points for the contest. The structure of this presentation is as follows. At first, I will share some general tips and tricks that hold for any web application, no matter which language or framework you used. And then I will relate this to UI5 based applications, so web applications written with OpenUI5 or SAP UI5. And then we come to the next option and we start with general knowledge again and then refine that or have a look in the light of UI5 based application for that option as well. Good so far? Okay, let's get started. The first one is a really trivial one. I get it. Of course, you need to update your dependencies. But I often see that not every project does that all the time. So I want to recap it here one more time. Updating dependencies brings you new features that come with the latest version of the framework, for example. It brings you bug fixes, so it makes web applications more stable. It brings security patches. It makes your web application more secure. And yes, it brings performance improvements, which come for you out of the box and you don't have to do anything most of the time. You just update the dependency, you update the framework, and tada, your web app got better. Awesome. So how does this look for UI5 based applications? Well, if you use the UI5 tooling, there are two places where you need to update or check dependencies for possible updates. At first, there is the project descriptor in the package.json file. In there, you find the dependency section and the dev dependencies section, and that lists all dependencies that you use and the version number. You can use tools like npm or yarn to make sure that all dependencies are up to date. Once you made sure that the dependencies are up to date, you also need to make sure in the UI5.yaml file that you use the most recent version of the framework. So in there, you don't only specify the type of framework, OpenUI5 or SAP UI5, but you also define the version that you want to use. And when you check these two places and make an update and restart the web application, make a new build, then you can be assured that you use the latest version. Talking about the build process, JavaScript minification and bundling is also an important topic when you have a look at the performance of your web application. I'm sure you already know that JavaScript is an interpreted language, which means that the source code is basically transferred as is from the server to the client, which is the browser in the case of web applications. And there basically the browser has a look at it. Okay, what do I need to do? What is written down in the source code? There is no compilation step in between. That means that all the comments, white spaces, long variable names that developers chose are still in there, which basically blows up the file size and which increases the time that is needed to transfer the file from the server to the client. But there's a way to work around it. You can minimize these files to basically remove all white spaces that are not needed, to remove long variable names, and this will basically not only decrease the file size significantly, but also make it faster to transfer the files from the server to the client. Talking about transfers, if you follow this pattern, you basically still transfer each file individually. And if you have a lot of files, that triggers a lot of HTTP requests, and that basically means there is a high repetition of the headers of these HTTP requests. So it does make sense to basically combine multiple JavaScript files into one bundle file and to transfer that file to save the HTTP header of the protocol. But there is also a disadvantage to this side. If a developer wants to debug the source code in the browser, that means he or she can only see the minified source code, which makes it hard, as it's harder to read these files for humans. But there's a solution to that we'll see in a second. Talking about minification, there are multiple tools in the developer ecosystem that you can use. There is Webpack, there is Grunt, but for UI5 based projects, you won't have to bother. You can just use the UI5 tooling, which abstracts everything for you away in this awesome UI5 build command. And then when you run UI5 build, you run this web application from the dist folder. And when you open the DevTools of your browser, you see there is a request to a so-called component preload file. And this file contains multiple original files that are all minified. You can have a look at them here in the preview, and I pre-printed them here to have some white spaces, but these white spaces are actually not part of the file as it is transferred. And there's another cool thing if you develop a UI5 based web application. You get the preload bundle with a minimized version of the file, but you also keep the original JavaScript file. That means if you want to have a look at the source code as a developer, you can hit this cool shortcut here on the keyboard, depending on your operation system, and open the technical information dialog, click this use debug sources checkbox, and then it will pull the original sources that you can inspect, and that won't happen in production. It's only for you there during development. The next point is optimize media encoding. So all roads lead to Rome, right? Can you spot a difference between these two images? I know that was a little bit mean because there is no difference in the image, but there's a difference in the file size of the images. So you see one file is significantly larger than the other. Yes, it has to do with the resolution, so don't store images in your web app in a resolution that you don't need. That just blows up the file unnecessarily. But you can also choose a file format that's more suited for the type of graphic, and that will also save you file size and megabyte eventually. Another thing that is important when we talk about media files like videos is that it doesn't only depend on the file type, but also on the encoding that you have chosen for the video. So also make that decision wisely and don't just copy and paste media files that you get from someone else into your web application. There are plenty of graphical tools that you can use to trim down the file size. What is important to keep in your mind is that the encoding that you chose needs to be supported by all browsers that your application needs to support. So there are some file types and file encodings that, for example, don't work on mobile phones or not on all mobile phones. So be aware of this pitfall. Awesome. Obviously, this holds for any web application, and there's no need to relate this tip or option for UI5-based projects. The next option that we have is to avoid or minimize blocking JavaScript or CSS and to load them on demand if there are requests that you cannot avoid or minimize. What does this mean? So here we see two charts of the requests that are triggered during the loading time of a application. Obviously, when all requests as here run sequentially, that's not good. So it's better if they run in parallel if possible, and also if you can reduce the number of requests. So I think it's clear to say parallel requests are clearly faster than sequential ones, but the best request is a request that you don't have to trigger yet. So that obviously means if you have some JavaScript logic, for example, that you can load later, prefer to load it later. Lazy loading is great. That does not only reduce the stress on the CPU of the client and on the network connection, but also on the CPU of the server, as it doesn't have to handle multiple requests at the same time. And again, this holds especially for media files, as they are typically very large. Okay, how does that relate to UI5-based projects? I'm sure most of you already enabled async bootstrapping of the UI5 library by now, but I want to recap it here one more time, as it is a very important lesson. So you can enable it in your index.js file, or index.html file, where you basically do the bootstrapping of the library, and then in the manifest.json, where you define the routing parameters. Another important thing that you shouldn't miss is make sure that your application doesn't trigger requests that are answered with 404, as you can see here. 404 requests are not only ugly, but can also be expensive, as shown here with these message bundle requests. That means your web application will at first try to load the language file of the browser setting. So when I access it in Germany, it tries to fetch the German files first. If that fails, it waits obviously until it fails, and then it will fall back to just a German localization file. So at first it tries to get German for Germans, then it just tries to get a general German file, which could come from another country such as Austria. And only then it will fall back to the English I18N file. And that already triggered at least 2 404 fails that extend the loading time of the application. So please make sure to have all I18N files in place that you want to support for your web application. Then caching is important, obviously. There are many ways how you can cache. Basically, in its widest form, a cache means to deliver a same response that you kind of saved from a previous request, and that decreases the load on the client, it decreases the load on a network, and it decreases the load on the server. There are many ways how you could achieve that. You could cache in the browser via your JavaScript logic with local storage, session storage, or a database that runs in the browser. You can cache on a network level, like when you use a content delivery network, for example, or you can cache in the backend or directly in the database. But as I said, this is not the focus of this presentation, and I don't want to go too deep into caching, as this is a topic that I could talk hours about. But let's have a look at how caching could work or does work in UI5 based projects. So obviously, I already mentioned it, there are CDNs, content delivery networks, where you could fetch the library resources from. So it might be worth that you check, is your application faster if you use a CDN compared to when you basically store all the library files in your web application as well. The second option would be to use the Service Worker API that is available in all modern browsers. That helps you to store to cache other resources that are not the standard UI5 libraries or SDK, for example. And if you run your UI5 apps from a ABAP server, have a look at a Cache Buster, which is also an interesting option for you. Then, perceived loading time, right? If your web app is slow, your users get annoyed. And it doesn't matter if it's your fault or if it's the fault of the backend, or maybe it's no one's fault, but that's just a fact. Your users will get annoyed. It might cost you money, as I mentioned in the beginning of this presentation. It might increase the bounce rate that your users say, nah, I just don't want to use this application. I'll do it later, I'll do it tomorrow, and then they forget it. So you want your users to be happy. Or a slowly loading page might just cause your users to think that the application is broken because they're just not patient enough. So what to do about that? Because there are obviously some applications that you cannot just make faster. There are technical limits that prevent you as a UI developer from improving this. But what you can do is adding a splash screen. And a splash screen can be animated, it can be as simple as a logo, but it definitely helps you to manage the expectations of your user and to manage the perception of the loading time. So just to add some more samples that you will see in the links that on the slide. So 10 years ago, Amazon found out that every 10 milliseconds of latency cost them 1% in sales. And Google found out that an additional half a second in this basically loading time for the search results basically led to a drop of traffic by 20%. These numbers, obviously, they change over time and you cannot adapt them one-to-one to your application, but they just show you how important waiting time is. And if you have a simple splash screen, as you see here, this already makes the users more comfortable and they know the application is doing something. If you want to find out how to implement this splash screen that you've just seen, have a look at Roland's blog post that I also linked here. And by the way, all the slides are available in the Devtoberfest repo. Okay, so far I told you about optimization options. These are only options that might or might not be useful for your project. But here is the most important optimization tip, or it's more a statement. Premature optimization is the root of all evil. This is not a quote from me. It's a quote from Donald Knuth. If you heard about him, if you haven't heard about him, type his name in your favorite search engine and you will see that he is an expert of the field for sure. But what does he mean with that? It's basically the same as the 80-20 rule that you might know from other areas, and basically says that 80% of your waiting time or loading time is triggered by 20% of your code. So it does not make sense that you try to optimize every single line of code of your web application. Please don't do that. It just takes a lot of time and you spend time that you might better invest in fixing the important parts of your code, just developing new features, and in worst case, you might even introduce new bugs when you modify code that is already working and you don't improve the performance. So please only improve the part of the code that is slowing you down. But now you wonder, how do I find out what is slowing me down? Well, your browser comes with many great developer tools. Here I just highlighted 3 of them: the network trace, the performance tab, and the lighthouse report. You can use all 3 of them for various tasks, and there are even more great tools in the dev provided by your browser. So have a look at them. The network trace, for example, helps you to find out which requests failed, how long did a request take, which request was stalled by another request, for example. And you see a nice waterfall chart that helps you to basically identify the pain points easily. There is also the performance profiler, which you can basically start, then do something on the website, like search for something, scroll, and then you stop the profiler. It will render a few seconds, and then it will also render charts for you to tell you, okay, how much time was spent in which function of the JavaScript code, how much time was spent waiting for a request. And then you can also use this to directly profile the feature that you just tested and to find out what slows it down. And there is the Lighthouse report, which gives you a numeric representation of your performance. You might argue about this report and how it comes to a number. I agree, but it is already great that it gives you a number that you can compare to the number of another web application. And this is a really powerful report. So if you haven't used it so far, I urge you to do it. And spoiler alert, if you participate in the coding challenge, you will have to use it. And it also makes you suggestions for improvements, which is also great that this is part of the development tools of your browser. Okay, let's have a look at the coding challenge. There is a repo that is linked here. It's also linked at the last slide. You basically can go to GitHub, go to this repository, fork it, clone it, install the dependencies, start a server locally, and improve the performance. I've shown you a few tips by now, so I'm sure you can apply the one or the other in here as well. And if you are sure that you are happy with the performance and it's above 75, so it only has to be above 75, there are no extra points or so, but obviously the more the better. And if you're happy, commit your changes, push them, make sure the changes are available on GitHub pages, and then open a pull request and it will automatically rate your application. But let's have a look at this flow in a demo so that you can see how this might work. Okay, there we go. This is the starting point of the Devtoberfest challenge. You see this repository here, you see the description of the repository, you see a link, and when you click on the link, you'll see an application. At first not, but then it boots up, it starts, and it shows you some services that are available on SAP BTP that you can basically also filter on. So far, so good. But when I open the DevTools of the browser and I run the Lighthouse performance score, you will see that the performance is actually not great at all. It takes a second or two to show up, but you will see this is a low score. Depending on the machine that you run it on and how fast your internet connection is, the score might be even lower when you run it at first. But it's your task to improve it, to get this number here over 75. For that, all you got to do is click on the fork icon, fork this repository with your user, and once the fork is done, clone it locally to your environment. Once you've done that, you can open the project with VS Code and just hit start here as well. When you start it, it might take a second or two, but then the application will start up here again. It makes sense to open the DevTools also here, and then you can start developing. For example, you could run the performance score here once again. If you run it locally, please be aware that it's probably slower because we are currently in a development mode. So when we go back to VS Code, you see that there are two scripts. There is UI5 serve, which is basically, and there's UI5 build. When you run a build script, then you get your data in this docs folder, and then you can use npm packages, you can use any tool basically to serve the folder of this docs directory. And this is what will be rated later on. So we won't rate how well your app does in development mode, we will rate how well it does in production deployment mode. Okay, then going back, you see the performance score is 2 here. This is really low, and this is what we want to improve. You could, for example, use the performance tab here that I mentioned before to trigger the profiling. Then you do a refresh, and while it's working, you basically can stop the profiling. It will load your profile. It might take a second or two for you to do that, and then you see which task required how much time and what was the slowdown, and here you see this overall pie chart, which is all very interesting. Obviously, I also mentioned this network trace here before. Let's have a look only at the fetch request. If we fetch here one more time, you see hint many sequential requests might also not be the best performance, and then you can use all these tools and the tips you saw previously to improve the web application. So one thing I could change, for example, is when I go to the code of the web app and I go to the view and I replace this message strip with the performance node, because that's something that you can remove. We won't need it later on, as this is only for you to be aware that this is part of the coding challenge. Then I save the file, it refreshes, and this node here will be gone. Obviously, this is not super helpful here because this change did not increase the performance score of the web application. Anyway, for display, let me just commit this in change, improve performance, save, and then I push the changes. The next thing that I can do now is go back to the GitHub web user interface. In here, I should momentarily see my latest push, and I also see this branch is 2 commits ahead of the upstream. So we can basically go to pull requests. Oh, one thing that is also important that you do it. Go to settings and make sure that you enable pages and you set it to a main branch and a docs folder to basically expose the application via GitHub Pages, so it can be measured. Don't worry if it won't find it immediately, it might take a moment or two. This will give you also enough time to go to the Actions tab and to make sure that actions are allowed. And basically also when you go here to Actions and say I understand this, and with the green button, you see that there are 2 actions that didn't run yet. But if we go back to the code, make a tiny commit, say that we name trigger action, now commit it, push it, you'll notice we didn't do a build so far. And I previously said we measure performance score of the production build. And this is what happens now. We made a change. There is a cool GitHub action up here that will on every push run the build command and basically save the web app. And when we go here again now, you see it triggered a new update, which will always make sure that you don't fix it, or it will make sure that you will always access the latest version of the web application via GitHub Pages and not an old version because you forgot to build the web application. While it's running, let's see if the GitHub page is already available. Not yet. Okay, let's wait a moment or two. I'll fast forward here. Okay, now we see that the action finished. You see the green check mark. Just out of curiosity, let's click on it to see all the steps that I completed that are obviously also marked with green check marks. Now let's go back to see if the GitHub page is ready. I refresh it and now you see, wow, there is my application now. Amazing. Obviously the performance is still not that great because I didn't make a significant change, but now I want to show you how you can submit it if you were happy with the current solution. So you go to pull request, say new pull request that you want to open against the original upstream repository. This is already selected by default. You see all your commit messages here, and then you can just go ahead and create pull request. Give any name, call it submission for coding challenge, and create the request. What will happen now is basically that it will run some checks. It will check, did you change the web application? So it's a different application. That would be cheating, obviously, and won't be accepted. It will see, is the web application still passing the test suite? It will see, is the web application or does it have a performance score that is better than 75 on its GitHub pages. So please be aware that you need to activate GitHub pages because it will measure the score from this source. It will run everything. So here you see, you can check the details. Obviously my test here won't pass the score right now. It will basically pull the data, it will run the score here. You can also see the URL that it's accessing to assess the score or to assess the Lighthouse report. So in case you run into problems, check if this is the URL where your application is available. Usually it takes only a minute or two to run the test, and then it will basically check, is the score above 75 or below 75. Actually, my performance score, okay, it closed. It was higher than expected, but still below 75. So it did not pass the minimum value. If it was above 75, basically in the pull request, you will be prompted for your SCN, SAP Community ID. And if you enter it there, I will make sure that you are assigned to the badge if you complete this in time, which means before this Friday. If you're below, you get an error message as shown here. It will say try again, add a new commit, push the commit, and the test will run again. And once you're above 75, then you will be prompted to ask to enter your SAP Community ID. The pull request itself won't be merged, so don't worry, if I close it, you will get your badge for sure. So much for the coding challenge. Let's jump back to the presentation. Okay, now that you understand the coding challenge and that you know what you're up to, it can get a little bit competitive now. So I got a Lighthouse score of 94. Can you beat me? I'm curious. Here is a slide with some resources. The first one is a link to a blog post that mentions the optimization options that I introduced in this post and many more. So please have a look at that post if you're curious. You'll find the UF5 performance checklist, which is always a great resource. The Devtoberfest repository, I'm sure you know it. This is where you can find this slide deck here. The Devtoberfest game board to see how many points you have, how many points you are missing to get on the next level, and obviously the coding challenge of week 6. Thank you for listening, and we'll see each other again at SAP TechEd 2021 in 1 week from now.